Hello everyone, today we're going to take a look at Theory D of paragraph 5.2, the quadratic formula. And what we're going to do is we're going to use the information and theory, particularly from theory C, to now take a look at what this means if I'm actually going to draw such an equation or a function, I should say. Because remember, if I have something of the form of this, I can just also say that graphically speaking, this is a parabola. And if I'm now going to take a look at what we discussed earlier with the discriminants, we said that if the discriminant has a certain value, I can then predict how many solutions it has, right? So if I'm going to take a look here, if d was bigger than 0, it said that it had two solutions. In this case, it means that the parabola has two x-intercepts. I'm going to show you in the next slide what this actually means. The box says d equals, there's one solution. Of course, there has to be a 0 here, right? So if d is equal to 0, there's one solution. That's a very special case if I would draw the graph of this formula or function. This parabola would be tangential to the x-axis. And tangential means in this case that hij me raakt the x-as, which means there is only one point of intercept. I'm going to show you that in a moment as well. If d is smaller than 0, there are no solutions, therefore the parabola has no x-intercepts. Then you say, sir, well, this is very abstract. Okay, let's just show you what this means. If I have a graph of the form y equals ax squared plus bx plus c, right, with a, b, and c just being any number, and a bigger than 0, then my formula looks something like, or my function or formula when I graph it looks something like this. They say when a is bigger than 0, because if my a would be smaller than 0, then I wouldn't actually have a cup but a cap parabola. And one of the homework exercises, I think exercise 23, you're going to make such an overview for yourself, but then when a is smaller than 0. Okay? If d is bigger than 0, I already showed you, I get two solutions, two values for x. And two values for x mean that this graph has two x-intercepts. So this is a sketch, of course, of how this graph is going to look like. If d equals 0, I only have one solution, and that means that I now I'm tangential to the x-axis, of point of tangency, they also call it. Dan noemen ze ook wel een raakpunt. Ze zeggen in het Nederlands dat de parabool dan de lijn raakt. If d is smaller than 0, we found that we had no solutions, right? If the discriminant was smaller than 0. And then maybe you thought, well, why is that the case? Well, this is the graphical representation of why this gives no solution. Because you're trying to search x-intercepts of this parabola, and you can try whatever you want, but it doesn't intersect with the x-axis, so you never find x-intercepts. And therefore, I have no x-intercepts, I have no solutions, right? So this is a graphical representation of what this actually means. That's what Theory D is all about. And how can I use that? Well, for example, these were examples of Theory C, if I remember correctly. Here, if I find two values of x, that means, in this case, that this has the form of, let's go back, like this. Why? My a is bigger than 0, my a is 1, so that means I have a cup parabola with two intersection points, so you can sketch it like this. And if you want to sketch it even more accurate, you can also say where the y-axis is, right? So for example here, axis to the left of the y-axis and this to the right, so you can also sketch the y-axis somewhere here. The book doesn't really tell you to do that, but you can do that if you want to. And for example, here in this example, the discriminant was not existing, so there were no solutions. A was 1, so it's still an existing cup parabola. It would look something like this. And in the last, there was only one solution. X was 2.5. Why there was only one solution? because the discriminant was 0. And this again is a cup parabola because A is positive. So this would look something like this. Okay? Practice this in exercise 23. You're going to make an overview for this for cup parabolas as well. For example, the examples here are only for cup parabolas where A is bigger than 0. I wish you good luck with doing that.